Now let's solve odd even linked list. In this problem, we're given the head of a singly linked list. We need to group all the nodes with odd indices together, followed by the nodes with even indices, and return the reordered list. So if we take a look at example 1, we need the elements at odd indices, so this first element, this third element, the fifth element, to come one after another, as you can see here, 1, 3, 5, and all the even indices, so 2, 4, and if we had other nodes, those as well, to come also after each other, so 2, 4, and then the even numbers need to come after the odd numbers. Or I should say, the numbers at even indices should come right after the numbers at odd indices, because we're not reordering the odd numbers first and then the even numbers. We could have even numbers at odd indices or odd numbers at even indices. Like in example 2, we have 1, 5, and 4. 1 and 5 are odd numbers, but they're at even indices. So all the numbers at odd indices first, and then all the numbers at even indices after those. So what they gave us in the problem is a list node head, and we need to return a list node. And obviously head is pointing to the very first node in our list, so we have a head pointer pointing at 1. And first and foremost, what we want to do is we want to check if head is equal to null, or head dot next is equal to null, and in that case we just return head. So if head is an empty list, then we just return head, which is null. And if head dot next is null, so if our list only has one node, then we just return head. And before we get into the meat of the code, there's one thing I want to emphasize on, and that's the fact that we must solve this problem with O of 1 extra space complexity and an O of n time complexity. So in other words, not only does our code need to be efficient, but we cannot create another list and then build that list as we go along. We have to rearrange the original list that they gave us. Now, if you notice, obviously the very first node is always going to be an odd index, right? 1 is odd. And the second node is always going to be an even index. And so right away what we can do is we can create two pointers. List node odd, which is equal to head. So we have, like I said, a head pointer that points to our first node. We're creating another pointer that's equal to head. So in other words, we're creating another pointer that also points to 1, which is odd. And we're going to create another pointer called even, which is equal to head dot next. Because remember, the second node is even. And if we have head pointing at 1, then head dot next is pointing at 2. And we just need to create a list node called even that's pointing at head dot next. So now we have a pointer called head that points at 1, a pointer called odd that points at 1, and a pointer called even that points at 2. And one more list node we need to create. We'll call this even head, and this is going to be equal to even. And so here's the idea. We have this pointer odd that points at 1. What's the next node that needs to come after 1? That's the 3. But we have a pointer called even, which points at 2. And so if we think about it like this, what's even dot next? What's the node that comes after 2? That's 3. So our first pointer odd, which points at next, odd dot next should point at 3. And so what we're going to do is we're going to say odd dot next is going to be equal to even dot next, since odd numbers come right after even numbers. And with that same logic, we're going to say even dot next is equal to odd dot next. So we have a pointer odd dot next should be 3. And we can access 3 because we have a pointer called even that points at 2. And we know for sure that even dot next is pointing at an odd node, or a node at an odd index. And so we set odd dot next to be equal to even dot next. And we know that an even index is going to come right after an odd index. So even dot next is going to be equal to odd dot next. Now, where list node even head comes in, that's equal to even. That means we have another pointer pointing at 2. So we have a pointer called even pointing at 2, and we have a pointer called even head that points at 2. And what we're going to do is we're going to update our even pointer so we can build our even list within our original list. And then what we're going to do is obviously we're going to update our even and odd pointers. So once we're done building our even list, we're always going to have an even head that points at 2, and we can update our even. And then in the end, what we're going to do is we're basically going to use even head to combine the odd list with the even list. So let's take a look at what that looks like. We're going to loop while even is not equal to null, and even dot next is not equal to null. So we're saying while we still have an even node and an odd node, then our list, we haven't gone through every node in our list. So while these conditions are met, like I said, odd dot next is going to be equal to even dot next, and then even. And then actually before we do that, we need to update our odd pointer to point at the next odd index. So odd is going to be equal to odd.next. In other words, we had odd pointing at 1, and we set odd.next to be equal to even.next. So we have odd that points at 1, odd.next that points at 3, and then we're going to update our odd pointer to point at 3 so we can traverse the rest of our list. And then we're going to say even.next is, even.next is equal to odd.next, and we're going to also update our even pointer. Now with our list complete, all we need to do is we need to combine the odd list with the even list, and that's where our even head comes in. So if you recall, we had even head that points at 2. By the end of this while loop, our odd pointer is going to point at 5. What we're going to say is we're going to say odd.next is equal to even head. So now our list is 1, 3, 5, and then odd.next is going to point at 2, and 2 now points at 4 because of this while loop. So odd.next is equal to even head, and all we have to do is return head. So let's submit our code and see if it worked. Fantastic. So that was the odd even linked list problem on LeetCode. I hope you found that video helpful, and thanks for watching.